Good afternoon to all of you. I'd like to discuss test paper 4's remaining question from 26 to 30 we'll do here. Let us start the job. Two bulbs consume same power when operated at 200 volt and 300 volt respectively. When the two bulbs are connected in series across a DC source of 500 volt, then ratio of, there are four choices. Potential difference across them is 3 is to 2. Potential difference across them is 2 is to 3, and power consumed by them 4 is to 9, and power consumed by them 2 is to 3. We have to find out potential difference relation as well as power consumption so that we can identify the correct one. Now here first condition given that power consumption will be same for 200 volt and 300 volt bulbs when it is operated. Now let us see, according to question, that power consumption we can write P equal to V1 square divided by R1 as well as equal to V2 square by R2. Now as we know V1 and V2 is known, so V1 by V2 whole square we can write like this, equal to 4 by 9, and of course this 4 by 9 will be R1 by R2. This relation will come from this equation. R1 by R2 means 4 by 9. Now when it is connected in series, then power consumption of each bulb will be like this. P1 will be I square R1 and P2 will be I square R2, and I will be that total voltage of the that is given here, that is 500 volt divided by total resistance R1 plus R2, that will give I, and I will be same for both the bulb because it is in series connection, so I will be same for both the bulbs. Therefore P1 by P2 we can write I square R1 divided by I2 I square R2. I square will cancel, R1 by R2. Already we got relation between R1 and R2, that is 4 by 5. That means 4 by 9. That means power consumption ratio will be 4 by 9. Now from the choices we can see choice number C is correct here, 4 by 9. Job number 27. A force F is applied at the top of a ring of mass capital M and radius capital R, placed on a rough horizontal surface as shown in figure. Friction is sufficient to prevent slipping. The friction force acting on the ring is, we have to find out how much friction force will act in this situation when external force F is applied at the topmost position of the ring. There are four choices. We have to find out the correct one. Now here we can consider a force will experience, friction force will experience at the lowest position of the ring, that is capital F suffix F, friction force. And according to question, force applied at the topmost position of the ring, that is F. Now as the ring moves towards right side, so we can take torque, net torque will experience on this ring, and that will be F into R. I mean torque here R cross F. R vector is centered to away and F is this direction, right side. So R cross F will give RF sin 90 degree. So we can write FR only. Its direction is clockwise rotation, means into the paper. Now for the friction force which is assumed here, F suffix F into R will be anti-clockwise, and this will be less than the value of clockwise torque. Clockwise means into the paper, anti-clockwise means out of the paper. Clockwise torque is more than this lower torque, I mean FF into R, due to friction force torque, and resultant will be how much? Now I into alpha. Alpha means angular acceleration. Here alpha means as there is no slipping at the lowest position, so linear acceleration equal to R into alpha. We can substitute A by R for alpha. Now from here we can see we know that moment of inertia for a ring is mr square into A by r square. R square will cancel. That means m into A will be there. That means F minus F suffix F equal to mass into acceleration of the ring. Now as it is moving in this direction towards right side, so center of mass acceleration will be how much? Now total force experiencing on the ring is F plus F suffix F, that is equal to mass into acceleration. Now from here we can see that F suffix F, friction force acting on the system, will be 0. That means friction force is 0 here. Friction force acting, you can understand the acting friction force during the motion. There is no friction force will play on this object as enough friction is available here. That is the condition, no slipping is taking place. Job number 28. Inside a long, straight, uniform wire of round cross section, there is a long, round, cylindrical cavity whose axis is parallel to the axis of the wire and displaced from latter by a distance small d. If a direct current of density J flows along the wire, then magnetic field inside the cavity will be there is a cylindrical, straight, long, uniform wire, and current density, let us say it is going into the axis. I mean, if we take a cross section on the paper, then cross section of the wire on the paper, then into the cross will give the direction of current that is into the paper. Now there is a cavity, and radius of that cavity is much smaller than the radius of the cylindrical wire. Now distance between center and the cavity center is small d. Now for this job, what we can assume, first we have to assume that there is no cavity throughout the cross section, current is flowing. Then the cavity portion, we can imagine current is coming from lower, I mean dot will be the direction of current flow. I mean it is perpendicular to the plane of the paper. In the opposite direction what we have taken in the for the entire cylinder, just opposite direction. That means the resultant current for that cavity portion will be 0, because initially we can assume that there is no cavity and total current is flowing in the according to the cross section. Entire cross section has same density. Now when we will take opposite current, definitely there you can neutralize and it will give the sense of cavity. Now we will solve this problem on the basis of this idea. Let us see. You can see in this diagram, this is a cross section of a wire, cylindrical wire, and direction of current density is J into the paper. J is a vector quantity, current density is a vector quantity, it is downwards. Now here is a cavity which is d distance away from the center of the cylindrical wire. This portion have a cavity that's radius is Cp. This is a P position. Cp is the radius. This radius is much smaller than the radius of the cylinder. Now initially we can assume that the entire current going, there is no cavity. Then you take this cavity portion current in the opposite direction. Summing these two, it will give 0 current. That means it will the sense will be clear. Now let us calculate magnetic field for a point, for a position P when we can assume that entirely there is no cavity, current is going into the paper. In that case, magnetic field at position P will be close integration B dot dl we know, and that is mu naught I. I means J into ds. Area means this area we are talking about. Area of this cylindrical having radius smaller. This one is the entire area. Now from here we can get B expression will be half mu naught J current density into R. That means half is constant, mu naught is constant, J is constant, so B is directly proportional to R. That is the expression we can use for this job. Now at position P, what will be the magnetic field when current density is entire cross section has uniform density and there is no cavity? That means it will be half mu naught J cross OP, because distance is directly magnetic field is directly proportional to distance. Already I have seen here, directly proportional to radius. So from here this will be the OP will be the distance here, because we are interested about P position. So J cross OP will be the direction of magnetic field as well as magnitude, both will be available from here. J direction downwards, cross you can see downwards, and P vector radially out. I mean OP vector radially out. So J cross OP vector will give tangential direction. That means somewhere if we draw a circle around it, this tangent will give, because downward current means clockwise tangent, I mean clockwise circle has to be drawn, it will give tangential direction, this direction, along this direction, tangent whatever it means. The point is selected such that from there their tangent will be drawn, that will give the direction of I mean perpendicular to OP will be the direction, perpendicular to OP will be the direction. Now for the say this the current is going in for this small cylinder in the opposite direction. So magnetic field for this portion will be J cross Cp. J cross Cp. This is opposite direction. That's why this minus has come, because it will give magnetic field in the opposite direction. So half mu naught. This is also cylindrical. J cross Cp will come. Now half mu naught can be taken common. We can write from here, we can write J cross OP vector minus CP vector. You can see in the diagram. OP vector, this one, and from here to here, of course, minus CP. That means we got this one. Till starting point to end point here, OP plus PC vector is OC vector. I mean, as we are interested about this one, that means this direction is opposite. So OP vector minus PC will give D vector OC vector, which is D. OP minus CP, again I am like to OP minus CP, because PC this plus this vector will give this one. Okay, now OP minus CP has come, because this direction is reverse, so minus will be there. That means we got this one. So OC will be coming here. That means D vector will come. In the question you have seen that it is given here distance D, where here parallel to the axis of the wire and displaced from letter by a distance D. If you take in terms of vector, it will be from O to C will be the vector. Now that can be replaced by D at D vector. Now your final expression is half mu naught J vector cross D vector. I think answer B is correct here. Now it is given in vector form, so we have to solve this problem in vector form. I think this one B is correct here. Half mu naught J cross D will be the resultant magnetic field. Next job 29. A particle is in linear simple harmonic motion between 2 points A and B, 10 centimeter apart, as shown in figure. This is the figure. A, B. Take the direction from A to B as the positive direction and choose the incorrect statement. We have to choose incorrect statement. There are 4 statements. We have to find out which one is wrong. Let us start the first. The sign of velocity, acceleration and force on the particle when it is 3 centimeter away from A going towards B are positive. It is correct, because A to B is positive. So when we are choosing some points C, where point is chosen A going towards B. The sign of velocity, acceleration, force on the particle when it is 3 centimeter away from A. From here 3 centimeter away, direction will be positive. Its velocity, acceleration. Once acceleration positive, the force is automatically positive. So A is correct. Next B, the sign of velocity of the particle at C going towards O is negative. C going towards O negative. This is positive, because direction taken A to B is positive. That means this statement will be the wrong one. Let us see the third C. The sign of velocity, acceleration and force on the particle when it is 4 centimeter away from B going towards A are negative. From B 4 centimeter away from B, I mean from B 4 centimeter away, all will be positive. I mean it is simple harmonically as it is returning here, so it is negative, because direction taken A to B is positive. So when particles coming this side, velocity will be negative, acceleration negative, as well as force will be negative. C is correct. The sign of velocity, acceleration, force of the particle, force driving from going from towards A is negative. It is negative, correct. Next, D. The sign of acceleration and force on the particle when it is at point B are negative. Up to B, when it was in along the direction of AB, it was positive. When it is at the point B, means momentarily it will come back. I mean velocity, acceleration, force all will be negative. That means B is wrong answer for this. Next one, number 30. The electron emitted in beta radiation originates from. The electron emitted in beta radiation originates from inner orbit of atoms, free electron existing in nucleus, decay of a neutron in nuclei, photon escape from the nuclei. C will be the correct one. Decay of a neutron in a nuclei. We know that for beta decay, 3 different type of beta decays are taking place. I like to give little information about it. For beta decay, 3 different type of beta decay takes place. When number 1, neutron in the nucleus transformed to a proton. Meaning neutron of the nucleus when transformed to a proton, in that case it will eject out electron and antineutron. This is antineutron, nu bar, antineutron, symbol of this is antineutrino. Now second situation, for this we know that X is the element, atomic mass, atomic number. So beta decay will take place and it will increase 1, that is known to you. Now number 2, when proton changes into neutron, in this case also emission of positron, in that case not electron, positron will emit, emission will take place positron. When proton transforms to neutron, in that case positron will come as well as neutrino. Very important information. Now number 3, electron captures. In that case also, suppose this substance X element electron absorbs, in that case it will have a Z-1 here, and just like this one Z-1, and it will emission will take place, neutrino will come out, and this 3 way we can get beta emission from nucleus. Thank you very much for good listening. Take care of all these questions, and next video will come up with a lot of good problems. Thank you very much.